So let's start talking about the mass of individual compounds. Let's do an example compound. Let's say like sodium chloride. We know this is an ionic compound, and we know that we name it this way. So here I've got sodium chloride. We know it's one sodium atom for every one chlorine atom because we do that drop and cross thing based on how many electrons I want to give or take, and that's sodium chloride. But keep in mind that sodium chloride is an actual physical thing. Just as that pen is an actual physical something floating around out there in the world, there is an actual physical sodium atom stuck to an actual physical chlorine atom. And together, when they're stuck together, they make sodium chloride. Now, on the periodic table, you have this number underneath the symbol, or underneath the name. And you know what this is. This is the average atomic mass. This is, in simpler but incorrect terms, that's what the atom weighs. It's how much stuff makes up that atom. And by stuff, we're talking about protons and neutrons. Remember, electrons don't really count because they don't weigh anything. They are almost massless. So if I've got a compound of sodium and chlorine, that compound, that formula unit for sodium and chlorine has some physical characteristics. There's a certain number of total protons and neutrons and electrons in there. There is weight or mass associated with a sodium chloride formula unit. Well, I know sodium is 22.99 AMU, and I can look over here. Oh, chlorine is 35.45. So together, the mass of a sodium chloride formula unit, or one piece of that compound, would simply be the two of those added together. Kind of makes sense that whatever the mass is of the compound is simply the sum of the masses of the atoms that make up that compound. So this one wasn't too bad as one sodium and chlorine, but we should have seen, or you should realize by now, that not all formula units are simply one of one and one of the other. If I had magnesium oxide, its formula mass is going to be the mass of one magnesium and one oxygen. But if I had potassium oxide, now this is different because now I've got two potassiums and one oxygen. So my formula mass is going to be two of whatever potassium is plus one of oxygen. So I go to the periodic table. And just for the course of this lecture here, we're going to keep it simple. Potassium's 39. We'll round this to the whole number. You won't do that when we're taking our time and doing this with the calculator. Potassium's 39. Well, I've got 39 twice, don't I? Oxygen is 16. Oxygen's average atomic mass is right at 16. So the mass of potassium oxide is two of these together, 78, plus 16. The mass of potassium oxide is 94. If you want to be more correct, we'll say those atomic mass units. So the important part is, how do I get that number? It is simply the masses of those elements that make up the compound added together. So if I had calcium phosphide, all I do is I add up calcium 3 times and I add it to the mass of phosphorus twice, and that gives me the mass of the entire compound. Seems easy, and it is. It's not too challenging, but there are some things you have to consider. We're going to write, let's say we get calcium, which is a +2, and the hydroxide polyatomic ion, which is a -1. So I cross and drop, and I get calcium 1 and 2 hydroxides. Now, how do I figure out the mass of this? Well, this is obviously, there's only one calcium. And calcium's mass is 40. That's easy enough. But the problem becomes the hydroxide. A hydroxide unit is 1 oxygen and 1 hydrogen. Well, oxygen is 16, hydrogen is 1, so together the mass of this thing is 17. But there's 2 of them. Remember, the subscript tells you how many of each thing you have in the atom. So there's 2 of this thing here. Well, that thing has a mass of 17, so 2 of them has a mass of 34, and the total mass of that ionic formula is going to be 74. That's the only hard part to this, is counting how many of each atom there are in the compound. You know that this compound here, strontium nitride, there are 3 atoms of strontium and 2 atoms of nitrogen. So to figure out the formula mass, well, I go to the periodic table, and strontium's about 88. Nitrogen's 14. So that together would add up to be my formula mass for that compound. Now, some of these get to be a little bit trickier than just this when we try to figure out how many atoms there are. Some of these ones with polyatomic ions especially. Let's say we go with, that's the ammonium ion. And you have a chart that shows you that it has a +1 charge. And we'll say we'll pair that with phosphorus, -3. So when we drop and cross, we get, that's the formula. That's the formula unit. Question becomes, how many of each atom do we have? Well, obviously we only have 1 phosphorus. We've got 3 of whatever this thing is. Well, this thing is ammonium. And this ammonium, each ammonium has 1 nitrogen. But I have 3 of them total. So I have 3 nitrogens. Well, inside the parentheses, my ammonium is made up of 4 hydrogens. But I have 3 of this ammonium thing. So I have 3 times 4, I have 12 hydrogens. So the harder part comes in when we have these polyatomic ions. And you have to remember that my subscript tells me how many of what I have in the parentheses. Let's take a look at another one. We can do, I like ammonium's good. Let's do ammonium phosphate. So now, how many of each atom do we have? Well, I've got 3 of whatever's in this parentheses. Well, what's inside the parentheses? 1 nitrogen. So I have 3 nitrogens, 3 times 4, 12 hydrogens. This is understood to be a 1, so I have 1 phosphorus, 4 oxygens. So if I want to know the formula mass for this guy, I have to add up the masses of 3 nitrogens, 12 hydrogens, 1 phosphorus, and 4 oxygens, and that would give me my formula mass, or how much does that unit of that compound weigh? What is its formula mass? Okay, so starting tomorrow, We're going to start looking at these compounds. We'll have a little bit of practice of, well, how many of each atom is in each compound. Now, you can see why we had to write these formulas correctly, because if you get the number wrong down here, if you thought phosphorus was a, if you say you messed up and you thought phosphorus was a -2, that's not the correct formula, which is going to give you the incorrect mass. So that's why we had to know how to do formulas first so that we can then get the mass right. And we'll need to get the mass right for the next thing that we're doing with these compounds.